This is section 11.2, part A, comparing distributions of a categorical variable. The two sample Z procedures of chapter 10 allow us to compare the proportions of successes in two populations or two treatments. What if we want to compare more than two samples or groups? More generally, what if we want to compare the distributions of a single categorical variable across several populations or treatments? We need a new statistical test. The new test starts by presenting the data in a two-way table. Two-way tables have more general uses than comparing distributions of a single categorical variable. As we saw in section 11.1, they can be used to describe relationship between any two categorical variables. In this section, we will start by developing a test to determine whether the distributions of a categorical variable is the same for each of several populations or treatments. Then we will examine a related test to see whether there is an association between the row and column variables in the two-way table. Marketing researchers suspect the background may affect the mood and buying behaviors of customers. One study in a supermarket compared three randomly assigned treatments: no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the number of bottles of French, Italian, and other wine purchased. Here is a table that summarizes the data. Calculate the conditional distribution in proportions of the types of wine sold for each treatment. So to do this, we are going to look when no music is playing first. So the type of music is playing. We are looking at just this category. There's no music playing. And when there's no music playing, 30 out of the 84 bottles that are purchased of wine are French, 11 out of 84 are Italian, and 43 out of the 84 are other. So about 36% are French, 13% are Italian, and about 51% are other. When there's French music playing, about 52% of the bottles of wine that are bought are French, about 1% are Italian, and 47% are other. And when the Italian music is playing, 36% are French wine, about 23% are Italian wine, and about 41% are other. Make an appropriate graph comparing the conditional distributions in part A. So to do this, we are going to make three different bar graphs. We're going to make one for when there's no music playing, one graph for when French music is playing, and another graph for when Italian music is playing. And we're just going to start our scale from 0, as high as we need, and graph the proportions of the different types of wine. Are the distributions of wine purchased under the three music treatments similar or different? Give appropriate evidence from parts A and B to support your answer. So the type of wine that customers buy seems to differ considerably across the three music treatments. Sales of Italian wine are very low at about 1% when French music is playing, but are higher when Italian music is playing at about 22.6%, or when no music is playing, which is 11.1% of the time. French wine appears popular in this market, selling well under all music conditions, but it's notably better when French music is playing. For all three music types, the percent of other wine purchased was pretty similar. In the example, we summarize the observed relationship between the type of music being played and the type of wine bought. The researchers expect that music would influence sales. So music type is the explanatory variable, and the type of wine bought is the response variable. In general, the clearest way to describe this relationship is to compare the conditional distributions of the response variables for each value of the explanatory variable. This is why we compared the conditional distributions of wine purchases for each type of music played. So let's check our understanding. The Pennsylvania State University has its main campus in the town of State College and more than 20 smaller Commonwealth campuses around the state. The Penn State Division of Student Affairs holds separate random samples of undergraduates from the main campus and Commonwealth campuses about their use of online social networking. Facebook was the most popular site, with more than 80% of the students having an account. Here is a comparison of Facebook use by the undergraduates at the main campus and Commonwealth campuses who have Facebook accounts. Calculate the conditional distribution in proportions of Facebook use for each campus setting. So we'll look at different types of settings. When students are on main campus, we're going to look at their monthly, weekly, and daily use. So out of the 910 people that were polled on main campus, 55 of them say they use Facebook monthly, 215 say they use it weekly, and 640 say they use it daily, or about 6% use it monthly, about 24% use it weekly, and around 70% use it daily. For the Commonwealth campus, they surveyed 627 students. 76 of them said they use it monthly, or about 12%. Weekly is about 25%, and daily is about 63%. Why is it important to compare proportions rather than counts in question 1? As you can see, the sample sizes are different for the two different campuses we look at. So if you just look at numbers, that's going to be very deceiving. We need to look at proportions so that we're comparing similar number types. Make a bar graph that compares the two conditional distributions. What are the most important difference in Facebook use between the two campuses? So if this is our bar graph, students on main campus are more likely to have everyday users of Facebook than are the students on the Commonwealth campuses. And those on Commonwealth campuses are more likely to use Facebook several times a month or less than those students on the main campus.